terms of this specific argument, mountain building and plate tectonics in general, them being uniformitarians, they would reject our position of a single catastrophic flood and event in the past. And so they'll say, well, these processes here, they'll argue that the geologic rates require millions of years for mountain building and plate tectonics. Is this true? What's the best way to engage that argument, Ryan?
Well, the answer to that is yes, they would under certain assumptions, right? If you're sitting at the bottom of the Grand Canyon and all you see is the little tiny puny Colorado River, and you sit down there for a week and you watch it and you measure the erosion rates, you're going to go, well, okay, I've been here for a week. I've measured these erosion rates. They're very, very minimal compared to this huge canyon. Therefore, this must have taken a really long time, right? But if you go back down to that same river in the middle of flood stage and measure the erosional rates, you're going to go, well, okay, hold on a second. I suppose this big old canyon may have happened a little faster than I thought, right? Because obviously when it's flooding, it can erode a lot more quickly, right? So when you add more energy to a system, you can do things a lot faster, which is exactly what creation is saying, is that there was a lot of energy in the system, and we had a catastrophic or runaway plate tectonics, and they moved at high rate and created these massive earthquakes that, you know, aren't recorded by Noah because he probably didn't feel them. You know, he was cushioned by all the floodwaters as he rode on the surface, right, and was tossed around just by the waves. But nevertheless, they were there. They happened, and we can see them in the rock record.
I'm curious, Ryan, in light of what you're saying there, and there's a lot of good points there. Are you familiar? And if you are, what are your thoughts on these subducted plates, these massive cold plates that you find basically miles and miles deep into the hot mantle that Dr. John Baumgartner describes as being pretty good evidence that this rapid runaway subduction, continental sprint, as some would say, rather than continental drift? Would you see those as being a good piece of evidence for what you're saying here on rapid runaway subduction, Ryan?
All I'm saying here is that the data that I compiled is consistent with that. Okay, I'm not. You can't actually take my fracture data and determine the rate at which things moved. All I can determine from the fracture geometry is the orientation of the stresses, and by that I can determine how those stresses change through time. And so I can tell you that in the geologic column, they didn't change, right? From the Cambrian all the way to the Miocene. And then they did a complete 180 and went into extension. And so that's consistent with the catastrophic plate tectonal model. It's not so consistent with some of the other animations that you'll see out there and the other models of, Pangea, Rodinia, and all these other names that they give to supercontinents colliding and breaking apart multiple times throughout geologic history.
Okay, I understand. And so when you mention the different names in the geologic column, we've got a question here, a good clarifying question, and we have a lot, so let me just make sure I can find it here. I appreciate all the engagement and interaction from our live chat. And so I think it's this one. Travis Statham, appreciate the question. And so he says, when you reference Permian and Cretaceous rock, etc., all these names, are you talking about millions of years and modern geologic consensus? I think already we know the answer to that is no. Or some kind of squeezed in together rocks that are all young?
So, I mean, the geologic column, you can look at it two ways. You can look at it as absolute dates, right? So the Permian is 500, or sorry, not the Permian, the Cambrian is 541 million years ago, right? And you get that from radiometric dating. Or you can look at it and you can say, well, the Cambrian is older because it's below, right, the Ordovician. And that's below the layer above it, right? So you get a relative sense of their age, right? So I do agree, that the Cambrian is the oldest rock unit, and you can use the geologic column in a relative sense, okay, to understand which rocks are older and which are younger. But I disagree that they are millions of years old, because I don't agree with the assumptions of radiometric dating, but that's a whole other topic. So relative, that's how I use the geologic column.
I like that. Relative versus absolute. We can even look at the dates in many ways as being relative, and again, not absolute, for reasons we could spend 3 hours on in another show. So I've seen some creation scientists, flood geologists, they'll say when it comes to these different layers, and I'm curious if you would see it the same way or even a similar way or a different way, which is fine too. They'll say that basically we're looking at community. So the Cambrian community, you've got the Permian community, Ordovician community, Mississippian community. And so they'd say rather than looking at it vertically, like we see in the textbooks, you can tip it to the side and view it horizontally. And so now you're looking at all these different communities being buried essentially at the same time, rather than evolutionary communities over time. Is that kind of an interesting way to look at it, Ryan?
Yeah, I'd say so. The vertical nature of it, of course, it doesn't exist anywhere that way around the world. But you can kind of imagine if you were to drill a hole over here vertically through those communities, right? When we're talking about the communities, you're talking about ecological zonations, and that would be talking about the fossils, right? But the rocks also change. So you have sandstones, carbonates, and different mixes and ratios of those things that help us define each formation. And you can go around and not only look at the type of formation, but you can go to very different parts of the world, and you can kind of get a sense where you are in the geologic column by looking at the type of rocks, even not just the fossils, and going, okay, wow, this looks a lot like those rocks in Colorado. So, okay, we must be in the Cambrian at this point. And sure enough.
Yeah, that's an interesting point. I'm curious, Ryan, when it comes to these mega sequences that we find in geology, could you answer the question essentially, what is the significance of these mega sequences, which is essentially the observation that sedimentary geologic layers are grouped in packages rather than separate entities? And the way that I understand it is they can be correlated worldwide. And if you could elaborate on that, perhaps, Ryan.
Yeah, so these mega sequences, you can talk to Tim Clary at the Institute for Creation Research on that, or he's kind of compiled a lot of that data. And these are pulses, really, where you have some uplift going on. So you've got some rocks that are rising out of the floodwaters as they're rising across the continents, right? And then they cover the mountains, and then those floodwaters might recede and go and, be more predominant somewhere else. And at another time, as you've got mountains rising somewhere else at a different time. So the structural, myself being more of a structural geologist like Tim, the structural goes hand in hand with the deposition, right? So where you have the mountains rising, you don't have deposition, and you have the deposition occurring in the basins. And so these mega sequences, talking specifically about the depositional events between the orogenic events.
Okay, very good. So in general, when it comes to these sedimentary rock layers, Ryan, that extend over entire continents and can be matched and clearly indicate a single catastrophic event, you're not convinced by those in the local flood camp, professing Christians, but they hold the old earth creation and the local flood theory. They'll say, well, okay, yeah, these are catastrophic events. So kind of like we talked about at the beginning, Ryan, to set the stage for the discussion, that they do hold a uniformitarianism, but with some catastrophism mixed in. And so they'll say these are local catastrophes making these geologic features still over millions of years rather than a single catastrophic event. But you're not convinced by that.
No, there's just too much going on in the geologic record, and too much connectedness and interplay that you can see between different areas, that it has to be really one event. And honestly, if you're gonna believe the Bible, why not believe all of it?
Right, right. Rather than just specific parts. I like how you said that, connectedness and interplay. I'm going to steal that from you. That's good.
Sure,
and that makes sense because, yeah, all that connectedness and interplay and the fact that they stretch over entire continents means that it couldn't have just been many local catastrophes over millions of years. No, it has to be one catastrophe to explain that correlation.
Yeah. If you saw like something being deposited over here and something over here, and they're completely different, right? There would be no reason to link them up. But when they start having similar characteristics, and maybe they've got similar patterns to the types of fossils and the order that those fossils are deposited, right? Which is what we see in the geologic column, even in the secular model, right? Then you start going, okay, well, this is too linked of a system. This is like key and lock fitting together. They're made to go together.
Yeah, I like that. There's linking. It's like a key and lock. They're made to go together. That's really good. It's a good rebuttal.